Hello everyone, I'm YC Yang from Vishay. The keynote topic I bring to you today is powering high reliability eFuses into EV solid-state power distribution systems. First of all, let me introduce you Vishay. We manufacture one of the world's largest portfolio of discrete semiconductors and passive electronics components. Our core spring is DNA of tech, including high quality, high reliability, essential innovation, and energy efficient. We are proud to be the good-to-manufacture for engineers to innovate it with easy and confidence that the DNA of tech is behind it all the ways. In power application, we can supply around 80% of your bone in power electron components, including discrete, semiconductor, and passive components. With Vishay 3.0 new era, meet our CEO, Joe Miko. He always say, our focus on customer first, business minded, and growth driven continue to guide how we approach every decision and action across the organization. Commitment to our customer and trust by many customers such as OEMs, EMS, and distributions. Market and technology leader in passive components, in wire wound and power resistors, the thin film SMD resistors, current sensing resistors, which later I will give you a summary, and liquid film resistors, power inductor and custom magnetics, capacitor for power electronics, wet and conformal coated tantalum capacitors. In semiconductors, we are leading in power rectifiers, TVS protection diodes, low voltage power MOSFETs, automotive power MOSFET, infrared components, and optical sensors. In a variety of different applications, there are variable different specifications. For example, you see the following specification. So the components provided by Vishay can meet the required specification accordingly, such as the automotive that we are mainly talking about today. We should meet SEQ 100, 101, and 200s. Speaking the current mainstream electric vehicle 800-volt application, Vishay provide many key active and passive components, such as high voltage battery 800 volt, active electrical suspension 800 volt, main inverter, and onboard charger. Vishay can supply many key active and passive in this area. Go to our main topic today, power distribution system. The key features of the PDS. Number one, solid-state relay technology. Our robust silicon carbide switch enable eFuses and solid-state relay, which provide fast, reliable switching and superior durability and response time is in demanding environments. Second, fast overcurrent detection. With Vishay low TCR current shunt resistor enable precise, high-speed overcurrent detection, less than 1 microsecond, and intelligent fuse management, ensuring near isolation of faulty circuit to prevent system damage, and reduce downtime. Number 3, pre-charge circuits based on high power, pulse-proof resistors alongside rugged semiconductor switches and gate driver. Our portfolio includes everything need to be conduct low-cost, reliable pre-charge solution for capacitive loads. Why need 800-volt eFuses? First of all, thermal fuses are slow and not resettable. Second, mismatch between durational current and short circuit protection. Of course, traditional circuit breaker use combination of magnetic device plus mechanical switch for short circuit protection. Like the major function of the eFuse. Now, we use the semiconductor switch for fast, resettable, non-acting current breaking. So you see the block diagram here. When the current go through the current sensor, go through the semiconductor switch, we can detect the through current and do the action we need. That's why we need 800-volt eFuse. When can the use of the eFuse bring advantage? Mainly in high voltage DC application, fast acting, controllable, or resettable fuse are needed. Usually, overcurrent protection of the silicon carbide MOSFET, where other solutions are not guaranteed to break the short circuit current with the short circuit withstand time of the silicon carbide device, especially high voltage and fast. Second, DC grid switching many times under full current, controllable, current limit. Number 4, electric vehicle charging equipment, switching high DC current, thermal protection of cables. Number 5, software-defined vehicle, SDV, like lighting, controllable, resettable, fast if used the protection components such as the silicon carbide inverters, such as in power distribution unit of auxiliary power. That's where we can use the eFuse and bring a lot of the advantage. Later I will show you the detail. Then how to size a 800-volt EV power distribution unit. Like 800-volt raw stabilization, usually you need a unidirectional eFuse. 5 kW peak is 3.58 ampere. Or go to the PTC heater, you also need a unidirectional eFuse. Total power is around 3 kW to 10 kW. The current is around 5 AM to 70 AM. Or like go to heat pump, you also need a unidirectional eFuse. The power is 7 kW duration, 10 kW for the peak. So total, you need the 12 amp duration and 17 amp peak. If go to the air curtain compressor, you also need a unidirectional eFuse. The power is 4 kW and 7 ampere. Or like the OBC, you also need a bidirectional eFuse. The total power such as 11 kW, 20 kW is more common in the market. The power and the current is 20 amp or even up to the 40 amp. So based on above all the application, we plan for the eFuse with around 3 amp to 20 amp or to 40 amp. This is needed for EV PDU. Look at the block diagram, how we plan, design the power distribution unit. Look at architecture. The layout is not difficult. So we need the eFuse board. Here, like the unidirectional eFuse 20M. You need with the controller. Then every power go via the PCB bus bar. Looks like this. The proof of the concept. Majorly, Vishay provide you the power stage. So this is a typical application and layout in the market. How it looks like of the PDU power stage. This design is based on Vishay silicon carbide MOSFET 1200 volt 45 milliohm silicon carbide MOSFET. Here is we just see the block diagram. So I take this area for example. We have the controller and the silicon carbide MOSFET as the switch. This unit is the eFuse function with the silicon carbide MOSFET for the fast switching and can precise detecting the current via the shunt resistor. So if you look at the simple channel available as the development board, take for example unidirectional eFuse 20M and 40M alternative. This is how the board looks like. If go to the 40M eFuse, the board is slightly large, and you see we need more silicon carbide MOSFET to handle the high power. Regarding the logic and control board, this is how the board looks like. The key function is very slow, low latency over current detection and silicon carbide MOSFET driving. Actually, inside the PDU, all 5 channels are controlled from the single Altera FPGA. Resistive current sensing is facilitated via the isolated SD ADCs. And the gate driver are optical isolated. Therefore, the isolated design allows for easy connection to the VCU. Let's look at what happened to the current in the event of a short. Let's see the graphic. When the short circuit event happens, to the eFuse works means we cut the short circuit off. It's around 1 microsecond, and in the conclusion, for the silicon carbide MOSFET, the short circuit withstand is 300 microseconds. So therefore, we need a very robotic silicon carbide MOSFET, and of course, very high accuracy current sensing. Later I'll show to you. Here I don't mention everything detail. So simply speaking, within 1 microsecond, the eFuse must work to protect all the system behind. So what happened to the shunt signal directing a short? As the previous page we mentioned, when the short circuit event happens, we need to make sure the eFuse function can cut it off within 1 microsecond. So based on our experience and our design with our silicon carbide MOSFET, and high accuracy shunt detecting the overcurrent, we can make sure all the eFuse board design can work within 1 microsecond when the short circuit event happens. This is our design. Vishay also provide the eFuse reference design with a Vishay silicon carbide MOSFET based on 800 volt 20 amp unidirection eFuse. Or if you need a high power, we also can support you 40 amp bidirectional eFuse reference design. This you can check with our Vishay website. We will provide you every detailed circuit documents, even datasheet. So make it simple to the designer. Outlook the Vishay custom eFuse module. We integrating low TCR shunt and silicon carbide MOSFET in compact, easy to use, and robust press fit module. So here you see it's a more common and public in the market ME pack with a Vishay new innovation package we call MAAC pack. This is more slim, light, and inside we can provide you, for example, 2 times 40 milliohm 1200 volt silicon carbide die in parallel. So total is around 7 milliohm. And one piece low TCR current sensing shunt with resistance value as needed by custom. Of course, this is basic function. You also can have an option like TVS, OVP, those of a function included. This is the Vishay custom eFuse module. So let's talk about the component inside. We just mentioned we design 1200 volt MOSFET die in the module. We also can provide you the discrete package. This is also automotive grade, already SOP this year. So we can support you ACEQ 101 qualification silicon carbide MOSFET 1200 volt 45 milliohm for your eFuse design into the PDU. Give you a rough idea regarding the silicon carbide MOSFET package roadmap. We start from the discrete leaded component and go into the SMD type. Even more further, we will develop in the double side cooling to enhance the thermal management. Of course, like the module design, we also can support you with the bare die. Like we just mentioned, there are 2 key components inside the eFuse design into your power distribution unit PDU. Number 1 is silicon carbide MOSFET. The second one is shunt resistor. This is an overview, give you the idea what kind of current shunt resistor you need based on the different power rating from the 0.4 watt go up to the 3 watt. This is multi-package. The size come from the 0603 up to the 2512, or even you need a more higher power from 3 watt to 10 watt, or go up to 12 watt. Vishay can provide you all kinds of current shunt, high accuracy sensing resistor. Okay, so I just quick update, give you what the importance of the PDU design into the 800 volt EV. And inside the PDU, you do need a good fast 18 accuracy eFuse board inside. So Vishay provide a lot of reference design. You can visit our website, check it, the reference design webpage. Here we will give you a lot of idea and a lot of good suggestion when you want to pick up the automotive grade component fit in your design. If you have more time, please learn more at www.vishay.com. This is our homepage. A lot of key component, detail, specification you need, all you can find here. Or please come to us. We will support you on site. Thank you for the attention.